Hello friends and welcome to YouTube channel on Engineering Mathematics by Dr. Navneet. In this today's video lecture, we are going to discuss about the Laplace transform of periodic function. So before starting with the example based on this topic, let me first define the concept that is called as periodic function. So periodic function. So definition of this periodic function is that a function f of t is said to be periodic if there exists a constant t, so that this t is greater than 0 such that f of t is equal to f of t plus t, or some people may write in a reverse manner. Some people may write this as f of t plus t is equal to f of t. So this is the definition of periodic function. Now to understand this periodic function, so let's take the example. Suppose if f of t is equal to, suppose this is cos of, suppose take this as cos of t, then check whether t is periodic, f of t is periodic or not. That means we have to check whether cos of t is periodic or not. So if we replace t by t plus 2 pi, then we can write this as cos of t plus 2 pi, and which is same as that of cos of t, because cos of t plus 2 pi is equal to cos of t, and which is the given function, which is the value of f of t. That means if we write f of t plus 2 pi is equal to f of t, so similar to that of this definition, then this function f of t is equal to cos t is periodic. So with the period, so here the value of period is 2 pi. Similarly, if we check for the function f of t is equal to sine of t, then this sine of t, as similar to that of this example, this is also periodic function with period 2 pi. So these are the example for the periodic function. Now let's discuss about the Laplace transformation of periodic function. So there is one theorem, so which is related to this topic. So this theorem is related to the Laplace transformation of periodic function. So now theorem. If a function, so statement of the theorem is, if a function f of t is periodic, if a function f of t is periodic with period a, better way we call this as, we can define period with period t. If f of t is periodic function with period t, then Laplace transformation of f of t is equal to, so we can take the Laplace transformation of this function, so which is 1 upon 1 minus e raised to minus ts into integration 0 to t e raised to minus st f of t dt. So this is the theorem, so which is related to the Laplace transformation of periodic function, and this theorem says that if a function f of t is periodic with period t which is greater than 0, then Laplace transformation of f of t is 1 upon 1 minus e raised to minus ts into integration 0 to t e raised to minus st f of t dt. Now to solve the example based on this Laplace transformation of periodic function, just find the value of this capital T. So that means we have to find the value of capital T, so that after finding this value, put the value of t, capital T here, period, and integration limit is also period, which is value of capital T. So put the value of capital T here. Again, put the value of f of t, find out the integration of this function. We will reach to the required solution to the given example. So this is the theory part. So this is one of the theorem related to this concept. Now let's take the example. So now suppose first example, we will take simple example. So example first, find Laplace transform of, suppose f of t is equal to t square. So take the simple example. So where 0 is less than t less than 2. That means this is the given interval for the term t, and if value of f of t is equal to f of t plus 2. That means this given example is periodic with period 2. So in question paper or in examination, you will get such type of question. Find the Laplace transformation of f of t is equal to t square and so on. So then how to know that this question is based on the Laplace transformation of periodic function? So this is the question behind the student. Then answer to this question is that whenever such type of function is there, then we know that this is the definition of periodic function, and because of this definition of periodic function, we will know, or we will understand that so given function is periodic, so we have to apply the Laplace transformation of periodic function concept. So now here given example is period, so we mentioned that given equation, so better way we call this as equation, given equation is periodic function. So given equation, or we may call this as given function, better way we call this as function. Given function is periodic with period, so capital T is equal to t. So because the definition of periodic function says that so f of t is equal to f of t plus capital T. If we compare these two parts, then we get the value of capital T as 2. Then by definition of periodic function, then by definition of Laplace transform of periodic function, so if we apply this concept, then if we write the definition here, then we get the value of Laplace transformation of f of t is equal to, so now put the value of capital T as 2 and value of f of t as t square. So we can write this as 1 upon 1 minus e raised to, so value of capital T is 2, so we can write this as minus 2s. Then so this is integration 0 to 2, because capital T is 2, then this e raised to minus st term as it is. Now put the value of f of t, value of f of t is t square, so we can write this as t square into dt. So if we apply LIATE rule, so according to this rule, exponential is the last function, so this is algebraic function, so we can take this as the first function, then we write this as 1 upon 1 minus e raised to minus 2s as it is. Then if we apply the general rule for integration by parts, so this general rule for integration by parts says that integration of uv dx is equal to first function, so this function as it is, then integration of second, integration of v, so this is v1 minus derivative of u, so derivative of u is u dash, again integration of v1, so which is v2 plus second derivative of u, which is u double dash v3 and so on. This is called a general rule for integration by parts. Now apply this rule here so that we can find the integration of this term. So first term is t square, that means u, into integration of second term, integration of e raised to minus st. So this is other than e raised to x, so derivative of minus st with respect to t is minus s, so that's why the denominator term is minus s. So first term, integration of second minus derivative of second, so derivative of t square, so derivative of first term is 2t into integration of this function, so integration of this function is e raised to minus st as it is, so upon derivative of minus st is minus s, so this minus become plus into s square. Again derivative of this function, so derivative of this function is 2, then integration of this function is e raised to minus st upon, this is s square into minus s, so we can write this as minus s cube. Now this integration is all because next derivative of 2 is 0. Now its limit is 0 to 2, so we can put lower limit as 2, upper limit as lower limit as 0 and upper limit as 2. So now in this way we find the integration of this term with the help of general rule for integration by parts. Now put the value of upper limit, put the value of lower limit and simplify. So we can write this as 1 upon 1 minus e raised to minus 2s, then in bracket, so first we are putting the upper limit, so write down some circular bracket. So upper limit is 2, so we can write this as minus 4, so 2 square is 4 upon s into e raised to minus, so this is 2s upon s. So after putting t is equal to 2, so then again this is minus, this is 2, again t is equal to 2, so this is 4 e raised to minus 2s upon, this is s square. Again if we take this minus sign common, then we get this as 2 e raised to minus 2s upon s cube. This is the value of upper limit, so one bracket. Again put the value of lower limit, so lower limit is 0, so if we put t is equal to 0, so 0 into something is 0, so this whole term is 0, so we can write first term as 0. Again for the second term t is present here, and if we put lower limit t is equal to 0, so 0 into something is 0, so this second term is also 0, so we can write second term as 0. Then this is minus sign, then we can write this as 2. Then e raised to 0, e raised to 0 is 1, so we can write this as 1 upon s cube. So in this way we put the value of upper limit and lower limit to the given example. So after putting the value of upper limit and lower limit, just simplify this equation. So if we try to simplify this equation, then we get this as 1 upon 1 minus e raised to minus 2s, then in bracket just simplify, so we get this as minus 4 e raised to minus 2s upon s first term as it is. This second term is also as it is, minus 4 e raised to minus 2s upon s square minus, this is 2 times e raised to minus 2s upon s cube. Then again this is minus become plus, so we can write this as 2 upon s cube. So this is the next step. Now afterwards it is not possible for us to simplify this term. So now it is always possible for us to take the term s cube common from the denominator. If we take x cube common from the denominator, then we get this as s cube into 1 minus e raised to minus 2s first term. Then in bracket we get this term as, so first term we take the term x cube common, so x cube upon s, so we can write this as minus 4 s square e raised to minus 2s. So after taking s cube common, so then this is minus 4s e raised to minus 2s, then this is minus 2 e raised to minus 2s plus 2. So this is the required answer of the given example when the given function is periodic function. So this is the easy method for finding the Laplace transformation of periodic function. Friends, this is the first example which is very simple for understanding this concept. Now let's take the next example. Now friends, let's take the next example. So next example is that, so this is the example. Question is, find the Laplace transform of, so find the Laplace transform of, suppose f of t is equal to k, which is constant, into t upon capital T. Then period for this function is 0 is less than t, less than capital T. And if the value of f of t, if the value of f of t is equal to f of t plus capital T. So now in question paper, how to know that this example is based on the periodic function? So to find out the Laplace transformation of this function, that means we have to apply the periodic function concept because of the condition given here. So value of f of t is equal to f of t plus capital T. So if we compare this given concept with the definition of periodic function, then we get the value of capital T as capital T. That means we get the same value for period. That means this is the given function which is periodic. So we can write this as given function is periodic with period. So given function is periodic with period capital T is equal to t itself. So then by definition of periodic function, so this is the definition of periodic function. So we can write by the definition of periodic function. Then put the value in this definition. So we write this as Laplace transformation of f of t is equal to, so this is 1 upon 1 minus e raised to. So value of capital T, so capital T is itself, so we can write this as minus ts, then integration 0 to t, then e raised to minus st as it is, and put the value of f of t. So value of f of t is given, which is k into t upon small t, so then into dt. So this is the given value for the function f of t. Now just find out the integration of this term. So we can write this as 1 upon 1 minus e raised to minus ts as it is. So in this equation, this k is constant, moreover t is also constant. So we can write this as k upon t, which are constant. Then remaining function is t and e raised to minus st. Again, as per LIATE rule, exponential is the last function. So we can apply general rule for integration by parts for t and e raised to minus st. So this is the general rule for integration by parts. First function, integration of second, minus derivative of first, integration of second, and so on. So here value of u is t and that of v is equal to e raised to minus st. So now apply this rule. So we get the answer to this term as first function t, integration of e raised to minus st is e raised to minus st upon minus s. So first function integration of second minus derivative of first, derivative of t is 1, then integration of second, integration of e raised to minus st is e raised to minus st, but this is other than t. So derivative of minus st with respect to t is minus s. So this is minus s into minus s, this is s square. Now next derivative of 1 is 0, so that's why this is the end of this example. Now its limit is 0 to t. So after finding the integration of this term by general rule for integration by parts, so we can put the value of upper limit and lower limit, which is 1 upon 1 minus e raised to minus t into s k upon t as it is. Then so put the value of upper limit. So upper limit is capital T. So we can write this as minus t e raised to minus ts upon s, replace small t by capital T. Then this is minus e raised to minus ts upon this is s square. This is the value of upper limit. Now put the value of lower limit. Lower limit is 0, so t is equal to 0, 0 into something is 0. So this is first term is 0 minus this is e raised to 0, so value of e raised to 0 is 1. So we can write the answer to this term as 1 upon s square. So now this bracket is over. So now once again simplify this term for our understanding purpose or for getting the clear result. 1 upon 1 minus e raised to minus ts, then k upon t. So in bracket we get this as minus t e raised to minus ts upon s minus e raised to minus this is ts upon s square, and this is minus minus plus, so we can write this as 1 upon s square. So now observe that, so for in the first and second term, if we take the term x square common, and we get this as 1 minus e raised to minus ts, which is present in the denominator. So for getting adjustment of this term, take these two term common, so we get next step as 1 upon 1 minus e raised to minus ts, then k upon t, so in bracket. So we get this as minus t e raised to minus ts upon s, plus after taking 1 upon s square common. So if we take 1 upon s square common from these two term, write first term as 1 minus e raised to minus ts, so this is minus sign. So now here is minus, so this is bracket. Now this bracket is over. So if we take this 1 upon 1 minus ts to the inner side, then next step is this is k upon t for the first term, then this t and this t will get cancelled, so we may write this as so k, then this term, this t will get cancelled, so we get this as e raised to minus ts upon 1 minus e raised to minus ts into this s term is there, so this s term as it is, so only t term will get cancelled for this first term, then plus this is k upon t as it is, this is k upon t. If we take this to the inner side, then this two term will get cancelled, so only remaining term is 1 upon s square. So in this way we get the solution to the second example. Now let's take some critical example for your practice. Now next example is, now friend, let's take the next example. So example is that, so to find out the Laplace transformation of f of t is equal to 1, and this value is minus 1, this is 1 for 0 is less than t less than a, and this is minus 1 for a is less than t less than 2a. So this is the given function, and if f of t is periodic function with period 2a. So straightforward, here they mention that given function is periodic function with period 2a, then we can apply the concept that is called as Laplace transformation of periodic function. So by definition, so we can write this as, by definition, Laplace transformation of f of t is equal to 1 upon 1 minus e raised to minus ts integration 0 to t e raised to minus st, then f of t dt. So this is the definition of Laplace transformation of periodic function. Now we have to find the value of f of t. So value of t is equal to 2a according to the Laplace transformation for the periodic function, or better we call this as, because of the definition of periodic function. So this periodic function is f of t is equal to f of t plus t. So if we compare this equation, then value of period t is 2a. Then, so to solve this example means find the value of capital T and put the value of f of t. But here f of t is splitted into the two parts, so that this integration 0 to 2a will get split into the two parts. First part is 0 to a and second part is a to 2a. Then if we put this value, then we get this as Laplace transformation of f of t is equal to, this is 1 upon 1 minus e raised to minus value of t, which is 2a into s. Then so this integration is, we are splitting it into two parts. So first part is integration 0 to a, limit is 0 to a, then e raised to minus st, then value for this function is 1 into dt, plus next interval is, this is a to 2a, then e raised to minus st as it is, then the value of given function f of t is minus 1, so we can write this as minus 1 into dt. So after putting the value of given function and given condition in the definition of periodic function, we get this step. Now next step is to find out the integration of this part and this part. So we can write this as 1 upon 1 minus e raised to minus 2as, then in bracket. So for the first function, 1 is constant and only single function is present, e raised to minus st. So integration of e raised to minus st is e raised to minus st upon minus s, limit 0 to a, because we know the integration of e raised to x is e raised to x. Here this is other than x, so derivative of minus st with respect to t is minus s. That's why denominator term is minus s. Now after taking this minus sign common, we get this as minus, again single function is present, its integration is e raised to minus st upon minus s, integration of e raised to x is e raised to x, so derivative of minus st with respect to t is minus s. That's why denominator is minus s, its limit is a to 2a. Now after getting integration of this term, put the value of upper limit and lower limit. So now we get this as 1 upon 1 minus e raised to minus 2as as it is. So now put the value of upper limit. So upper limit is a, so we can write this as e raised to minus, this is as, because we here integrate with respect to t, that means put the value of upper and lower limit for t. So that's why t is equal to a upon, this is minus s, this is upper limit, minus value of lower limit is 0, so e raised to 0 means 1, we write this as 1 upon s, so this minus sign as it is, upper limit minus lower limit. This is for the first term, minus, again put the value of upper and lower limit for the second term, we get this as e raised to minus 2as upon minus s for the first term, so we can write here circular bracket, minus value of lower limit which is a, so we write this as e raised to minus a s upon minus s. So now this is over, moreover this curly bracket will also get over. So now once again simplify this term, we get this as 1 upon 1 minus e raised to minus 2as, then in bracket. So if we simplify this term, then we get this as e raised to minus as upon minus s, or we may write this minus sign here for understanding. This is minus minus plus, this is 1 upon s, then again this is minus and this is minus, this is plus e raised to minus 2as, then again this is minus minus plus, we write this as e raised to minus as. So in this way we get the solution. Now here denominator is s, here is also denominator as s. If we take the denominator s common from all the four terms, then we get next step as 1 upon, so s is common from all the value of denominator, then 1 minus e raised to minus 2as, then in bracket, so we get this term as, this is 1, then this term, and sorry here this is minus, okay, this is minus minus plus, this sign is minus minus plus, again because of this minus sign, this sign is minus, so here we make the mistake. So this is minus, minus minus become plus, and again this is minus sign, so this become minus sign. So now if we try to adjust this term, then this first term and last term is same, and if we rearrange this term so that we get the square of one term, so this one as it is, then this term is minus 2 times e raised to minus as. So after taking the addition of the first and last term, then plus this is e raised to minus 2s. Now observe that this term is the square of term. This is of the type 1 minus 2 a minus 2ab plus b square. So this is a square minus 2ab plus b square. We know that this is a plus a minus b its square. So according to this formula, so we can write this as 1 upon, this is, first we will write this term, so this is 1 minus e raised to minus as, then its square. This is the perfect square of this number. So then to cancel this term from numerator and denominator, we will adjust denominator term as, so s into 1 minus e raised to minus as and 1 plus e raised to minus as. So if we take the product of these two numbers, then we get the original equation as it is. So now, so one term will get cancelled. So this term and this power will get cancelled. So we get next step as 1 minus e raised to minus as upon, so this is s into 1 plus e raised to minus as. So now this is the answer related to the question f of t is equal to 1 and minus 1. So we apply the concept Laplace transformation for periodic function. Now this is the third example. Now let's take some critical example for your understanding. Now next example. Friends, now let's solve some critical example based on the Laplace transformation for periodic function. So now example is, find the Laplace transformation of f of t is equal to t by a, where t lies between 0 and a, and value of f of t is 2a minus t upon a, when the value of t lies between a and 2a, and it is mentioned that f of t is equal to f of t plus 2a. So now friends, because of the condition f of t is equal to f of t plus 2a, given example is periodic function after comparing with the definition of periodic function. So here the value of period t is 2a. Then if we apply the Laplace transformation of periodic function concept here, then Laplace transformation of f of t is equal to 1 upon 1 minus e raised to minus st integration 0 to t e raised to minus st f of t dt. This is because of the theorem of the Laplace transformation for periodic function. Now in this theorem, put the value of capital T, which is 2a, and the value of this function f of t, but this function f of t is splitted into the two parts. So that's why let's split this integration into the two parts. So we can write next step as Laplace transformation of f of t is equal to, this is 1 upon 1 minus e raised to, so put the value of t, which is 2a, so e raised to minus 2as, then in bracket we get this as integration. So first interval is 0 to a, we can write this as 0 to a, then e raised to minus st as it is, then value of f of t is t by a into dt, plus next interval is a to 2a, so we can write this as a to 2a, then e raised to minus st as it is, then value of f of t is 2a minus t divided by a into dt. So now in this way we write this step according to the theorem for the Laplace transformation of periodic function. So find out the integration of this term, integration of this term. So but in the first and second integration, this 1 upon a and 1 upon a is common for both the integration, and which is constant term. Now take outside the integration, so that we can write next step as 1 upon a into 1 minus e raised to minus this is as, then in bracket. So remaining term is integration of t e raised to minus st, right? So this is the remaining term. So now to find out the integration of this term, so apply the general rule for integration by parts. According to the general rule for integration by parts, value of u is t and value of v is e raised to minus st. When this rule says that first function integration of second minus derivative of first integration of second and so on. So first function is u, second function is e raised to minus st. So if we apply this concept here, then we get this as first function t integration of second term, which is e raised to minus st. Derivative of minus st with respect to t is minus s. So first function integration of second minus derivative of first function, derivative of t, which is 1, into integration of this function. So integration of this function is e raised to minus st upon minus s into minus s. So this become s square. Now next derivative of 1 is 0. That's why this integration is over. Its limit is 0 to a. So we can write its limit as 0 to a. Plus, so here again, so in the next integration, so remaining term is, so this is 2a minus t, so this is 2a minus t, then e raised to minus st. Now for solving this integration, apply general rule for integration by parts. So here the value of u is 2a minus t and that of v is e raised to minus st. Apply this rule so that we get this as first function, this is 2a minus t, first function 2a minus t into integration of second, so which is e raised to minus st upon, this is minus s. First function integration of second minus derivative of first. So derivative of 2a minus t with respect to t is minus 1. So we can write this as minus 1. Again integration of this term. So integration of this term is e raised to minus st upon minus s into minus s. So this is s square. So now this is over. Now next derivative is 0. That's why this integration is over. Its limit is a to 2a, more or this curly bracket is also over. So now next step is to put the value of upper limit and lower limit and simplify. So we can write next step as 1 upon a into 1 minus e raised to minus 2as, then in bracket. So put the value of upper limit first. So if we put the value of upper limit first, write down circular bracket. Upper limit is a, so we can write this as minus a e raised to minus as upon s after rearranging the term. Then this is minus e raised to minus as upon, this is s square. This is upper limit for the first term minus lower limit. So value of lower limit is 0. So 0 into something is 0. So this first term is 0. This is minus. So 0, e raised to 0 is 1. So we can write this as 1 upon s square. So this is the value of upper limit and lower limit for the first term. Similarly, put the value of upper and lower limit for the second term. So we can write second term as, so second term is, so bracket upper limit. So upper limit is 2a. So if we put t is equal to 2a, then this 2a and this 2a will get cancelled. So some 0 into something is 0. So this first term is 0. Then this is minus minus. We can write this as plus. Then we get this as e raised to 2 minus 2as upon, this is s square. This is upper limit minus, we can write the value of lower limit. Lower limit is a. So this is 2a minus a. So we get this as a. So 2a minus a is a. So we can write this as minus sign into a. Then again this is e raised to minus as upon s. So after putting the value, so then this is minus minus plus, then this is again e raised to minus as upon, this is s square. So this bracket is over, this bracket is also over, right? So now after writing this step, so just simplify this. We get this as 1 upon a, 1 minus e raised to minus 2as, then simplification. So now simplify this term and rearrange the term so that we get some standard result. Now here this is minus a e raised to minus as upon s. This is the first term, minus e raised to minus as upon this is s square, and this is minus minus plus 1 upon s square. This is the third term. Now next is plus e raised to minus 2as upon, this is s square. Then this is again minus minus become plus, then this is a e raised to minus as upon s. Again this is minus minus plus, this is minus e raised to minus as upon, this is s square. So after simplifying all the terms, so we get such type of term. So but here observe that, so this first term and this last second last term is same with alternative sign. So this is minus, this is plus, these two term will get cancelled. Then moreover, so it is always possible for us to take the term s square common from the denominator of remaining term, and this term is repeated twice. This is 1 minus 2 times this term into this, so that we get the square of this term. So we may write this as 1 upon a into, so after taking s square common, so we write this as a s square 1 minus e raised to minus 2as, then so remaining term. So remaining term, this is 1, so this is 1. So if we take first and last term, so this term is repeated 2 times. So this is e raised to minus 2as plus this term, which is e raised to minus 2as. Now observe that this is the perfect square of, so we can write next step as, so this is 1 upon a s square 1 minus e raised to minus 2as, then this is the perfect square of 1 minus e raised to minus as, its square. So this is the square of this term. So now to cancel this term with the help of denominator term, so we can readjust the denominator term as, so this is 1 minus e raised to minus as, its square divided by, so we can write denominator term as 1 a square in bracket. So this is 1 minus e raised to minus 2s. So we can readjust this minus 2as term as 1 minus e raised to minus as and 1 plus e raised to minus, this is as. So that after taking product of these two terms, we get original term as it is. Then it is possible for me to cancel 1 minus e raised to minus as term, so that final answer is 1 minus e raised to minus as upon as square 1 plus e raised to minus as. So this is the answer. So now this is one of the critical example for the Laplace transformation of periodic function. So this is the fifth example. Now let's take the last sixth example of this topic, which is more critical than the example which we learned up to this step. Now next example is, hello friends, now take the next and last example of this video lecture. So this example is somehow critical, that's why we are discussing this example here. So find the Laplace transformation of f of t is equal to a sin pt for the value of t between 0 to pi by p, and value of f of t is 0 when t lies between pi by p to 2 pi upon p, and value of given function is periodic function, f of t is f of t plus 2 pi upon t. So in question paper, so this example may written in alternative form as f of t is equal to a, this is sine of omega t, and this value is 0, sine of omega t when 0 is less than t, less than pi by omega, and this value is, so we can write this as pi by omega is less than t, less than 2 pi by omega, and given function is periodic with the period f of t is equal to f of t plus 2 pi upon omega. So in examination they may ask the question with the help of p, and they may replace p by omega sign. Meaning of this question and this question is same, either you solve this way or this way. So we are trying to solve this question with the value p. So you only replace p by omega. Now observe that given function is periodic function. Given function is periodic function because of this part. So according to the definition of periodic function, so we can write this as f of t is equal to f of t plus capital T. Now the value of capital T is 2 pi upon p. So now because of this part we apply the concept that is called as Laplace transformation of periodic function. So if we apply the concept Laplace transformation of periodic function, then we write this as Laplace transformation of f of t is equal to integration this is 1 upon 1 minus e raised to minus ts, then integration 0 to t e raised to minus st, then f of t dt. Now to find out this integration means put the value of capital T, which is 2 pi upon p, and put the value of function f of t. But here f of t is splitted into the two parts. So let's split the integration 0 to 2 into two parts. First part is 0 to pi by 2 and second part is pi by 2 to 2 pi by p. So now we can write according to this definition as Laplace transformation of f of t is equal to 1 upon, so we write this as 1 minus e raised to value of t, which is 2 pi, so we can write this as 2 pi upon p into s. Then given integration is splitted into the two parts, that's why curly bracket. Then first function interval is 0 to pi by p, so this value is 0 to pi by p. Then e raised to minus st, this is e raised to minus st, and for this interval 0 to pi by t, value of this function f of t is a into sine of pt dt. So this is for the first function. Now second function is plus, next interval is, this is pi by p to 2 pi by p. Then for this interval, so e raised to minus st as it is, then put the value of f of t. For this value f of t is 0, so we can write this as 0 dt. Now observe that because of this 0 term, so this whole term, second integration term becomes 0. Now only simplify the first term. So in first term, this 2 is constant, so we can take outside the integration. So we write this as 1 minus e raised to minus 2 pi upon p into s, then integration, this is 0 to pi by p, then e raised to minus st into sine of pt dt. So after writing or rewriting this term for the understanding this concept simply, so we get this term. So now after that, so to find out the integration of this term, so for finding the integration of this term, general rule for integration by parts is not valid, so this rule is not valid. So now in this case apply the rule. So integration of e raised to alpha x into sine of beta x dx is equal to e raised to alpha x upon alpha square plus beta square, then in bracket we write this as alpha time sine of beta x minus beta time cos of beta x. So now this rule is applicable, this rule is already known to you, so from your first first semester. Now apply this rule to solve this integration. So if we try to solve this integration with the help of this rule, then here we get the value of alpha as, so after comparing this term and this term, we get the value of alpha as minus s, and that of value of beta. So value of beta after comparing this sine of pt and sine of beta t, we get value of beta as p. Right? So now apply this rule, we get next step as, this is a upon 1 minus e raised to minus 2 pi upon p into s, then in bracket we get this term as e raised to alpha x, that means we get this as e raised to minus st. So value of alpha is minus s, so e raised to minus st as it is. So upon alpha square, that means minus s square is same as that of the s square, plus beta square, that means this is p square, then in bracket alpha, so value of alpha is minus s into sine of pt, so we can write this as sine of pt, then minus beta, value of beta is p into this is cos of pt, so its limit is 0 to pi by p. So after integration, after taking integration of this term with the help of this rule, we get this step. Now next step is to solve this integration. That means to solve this integration means put the value of upper limit and put the value of lower limit. Now to understand this concept clearly, so we can write next step as 1 upon 1 minus e raised to minus 2 pi upon p into s as it is. Then we are putting the value of upper limit, so write down one circular bracket. So upper limit is 2 pi. So here the value of upper limit is 2 pi, so we can write this as e raised to this is only pi by p, so we can write this as e raised to pi by p into s upon this is s square plus p square, again in bracket. So when we put the value of upper limit for this term, then we get this as sine of p into value of t is pi by p, so we get this as pi by p, so which is sine of pi, and we know that value of sine of pi is 0, so value of this first term is 0, minus, so this p, then again put the value of t for this second term, this is cos of p into pi by p, so we get this as cos of pi, and we know the value of cos of pi is minus 1, so we can write this as minus minus, or better way for our understanding we can write as it is, so this is minus p into minus 1, so write down as it is. So now this bracket is over, so now this upper limit bracket is over. Now again put the value of lower limit. So if we try to put the value of lower limit, then lower limit is 0, so e raised to 0 is 1 upon this is s square plus p square as it is, then again in bracket, so here we get the value of t is equal to 0, then we get this value as sine of 0, so that sine of 0 is 0, so we can write this as sine of 0 is 0, so now this term is 0, again minus, so just simplify this term, so after taking minus sign we get this as p, then cos of 0, so we know the value of cos of 0 which is 1, so again we can write this as 1, so this bracket is over, now this lower limit bracket is over and this bracket is over. So this is the value after putting the value of upper limit and lower limit for the given equation. Now after simplifying this term, so we get this as a upon 1 minus e raised to minus 2 pi upon p into s, then in bracket we get this as e raised to minus pi upon p s upon s square plus p square, then this is minus minus become plus, so we get this as p, then this is minus, so this is 1 upon s square plus p square, again this is minus and this is minus, minus minus become plus, so we can write this as ap e raised to ap, so this is p common, so here is also p, so this is minus minus become plus and this p as it is, so from numerator it is always possible for me to take the term p common, so ap upon this is 1 minus e raised to minus 2 pi upon p into s first term, then this is s square plus p square as it is, so from denominator it is common term, then remaining term is 1 plus e raised to minus pi upon p into s. So this is the adjustment from the numerator, 1 plus e raised to minus pi upon p into s. So now to cancel this term and denominator term, so let's rewrite denominator term as, So we can write this as AP, then 1 plus e raised to minus pi upon p into s divided by, so we write first term 1 minus e raised to, this is e raised to minus 2 pi p upon s, we can write this as e raised to minus pi upon ps, this is the first term, then this is plus e raised to minus pi upon ps, so that after taking product of these two number we get original number as it is. This is just an adjustment of the term into s square plus p square as it is, so that this plus and this plus term will get cancelled, and final answer to this question is AP upon 1 minus e raised to minus pi upon p into s into 1 upon s square plus p square. So now this is the final answer of this question. Friends, I hope you like this lecture. Now let's take some example for your practice. So now let's take some exercise. Now friends, time is to test your knowledge. So now to test your knowledge, so here 7 examples are given for your practice. Solve these examples which are very simple. So this is first example, f of t is equal to t, so value of period is 1. Then this is f of t is equal to t and pi minus t, value of period is 2 pi. So f of t is equal to t and 0, here again value of period is 2. Then f of t is equal to mod of sine omega t and mod of cos of omega t, t is greater than 0. And f of t is equal to e raised to t for the period 2 pi, and last example is f of t is 1, 0 and minus 1 for the period 3. So friends, I hope you like this lecture. So thanks one and all.